0.10. A polystyrene foam ice box has a total area of 0.950 meters square and walls with an average thickness of 2.50 centimeter. The box contains ice, water, and canned beverages at 0 degrees Celsius. The inside of the box is kept cold by melting ice. How much ice melts in one day if the ice box is kept in the trunk of the car at 35.0 degrees Celsius? So, the given values in the problem, which are the area of the polystyrene foam ice box is equal to 0.950 meters square, and the thickness of the walls of the polystyrene foam ice box, or D, is equal to 2.50 centimeter in meters 0.025, and the temperature cold is equal to 0 degrees Celsius, and the temperature hot is equal to 35.0 degrees Celsius, and the thermal conductivity for the polystyrene foam found in table 1.5 is equivalent to 0.010 watt per meter degree Celsius, and the latent heat of fusion is equal to 334 kJ per kilogram, is equivalent to 334 times 10 cube, or 334 multiplied by 1000 is equivalent to 334,000 J per kilogram. And also the time is equal to 1 day. 1 day is equivalent to 24 hours, and 24 hours is equivalent to 1,440 minutes, and 1,440 minutes is equivalent to 86,400 seconds. So in this question involves both heat for a phase change or the melting of ice and the transfer of heat by conduction. So first, we will solve for the mass of the ice. But before that, before we can solve the mass of the ice, we will first find out the value of the net heat transferred, which we can get the value of net heat transferred if we won't have the value of the P, or the rate of conductive heat transfer. So first, we will solve the rate of conductive heat transfer using the formula P equals to dq over dt, or equal to Ka multiplied by the temperature H minus temperature cold all over D, or divided by D. So, where P is the power rate of the heat transfer in watts or in kilocalories per second. D is the thickness or the average thickness of the walls of the polystyrene foam ice box. Th minus Tc is equivalent to is the temperature difference across the slab, and K the thermal conductivity, and A the total area of a polystyrene foam ice box. So after that, we will substitute the known values. So the thermal conductivity of the polystyrene foam is equivalent to 0.010 watt per meter degree Celsius multiplied by the area 0.950 meters square, and multiplied by the temperature difference is equal to 35.0 degrees minus the Tc 0 degrees Celsius all over the thickness, or D, is equal to 0.025 meter. So first thing I did, or akong gibuhat una, is gimultiply na ko ang thermal conductivity og ang total area, which is nagresult sa 0.0095 watt meter. Meter siya kay na-cancel ang meter cancel ang meter, isa na bilhin, multiply, so 0.0095 watt meter per degree Celsius. Then, after, gi-minus na ko ang temperature, which is nag-result siya sa 35.0 degrees Celsius. After that, gi-multiply na ko ang duha ka-result. Cancel ang both degrees Celsius, kay per mani, so over siya, cancel both. So, multiply din ako ang 0.0095 multiplied by 35.0 is equal to 0.3325 watt meter. Then, copy the denominator, which is 0.025. After that, dinhin na din nato ni sila i-divide. I-divide na to ang 0.3325 divided by 0.025 meter. So, cancel the variable m, then divide the constant, which resulted to 13.3 watt. Watt siya, kaya ang variable nga m na-cancel naman. So, copy the remaining variable. So, P is equal to 13.3 watt. After that, kinakuha naman nato ang P or the rate of the heat transferred. Nakuha naman nato, so makuha na nato ang Q or the net heat transfer. So net heat transfer is equal to PT, which is the rate of the conductivity of the heat transfer multiplied by the time. So substitute the known values, 13.3 watt multiplied by the time, 86,400 seconds. So, nag-result siya sa 1,149,120 watt second. It is equivalent to 1.15 times 10 to the power of 6 joules, which is Ws is same ra sa joules, 1 joule. So, kaya nakita naman nato ang net, nakita na nato ang net heat transferred, pwede na nato nga makuha ang mass, which is mag-derive ta sa formula nga Q equals MLF, or the latent heat of fusion. Ang LF latent heat of fusion. So, kay mas man natong gipangita, ang kani nga formula ato siya i-rumble para makita nato ang M, which is ato ni i-divide ang LF to find out the M. So, M equals Q over LF is so mo na ni siya ang formula nga to gamiton. M equals Q over LF is equal to Q 1.15 times 10 to the power of 6 joules divided by the latent heat of fusion, 334 times 10 to the power of 3 joules per kilogram. So, is equal to 1,150,000 joules divided by 334,000 joules per kilogram is equivalent to 3.34 kilogram. Therefore, there are 3.34 kilogram ice melts in one day if the ice pack is kept in the trunk of the car at 35.0 degrees Celsius. So, example 1.11. A steel rod and an aluminum rod, each of diameter 1.00 centimeter and length of 25.0 centimeter, are welded end to end. One end of the steel rod is placed in a large tank of boiling water at 100 degrees Celsius, while the far end of the aluminum rod is placed in a large tank of water at 20 degrees Celsius. The rods are insulated so that can heat escapes from their surfaces. What is the temperature at the joint and what is the rate of heat conduction through this composite rod? So, ang gipangita is ang joint temperature sa duwa sa steel o sa aluminum. Then, ang ilang rate of heat conduction. So, first, the given in the problem or the length of the steel is same as the length of aluminum. So, 25 centimeter into meter, 0.25 meter. So, ang area sa steel is 7.85 times 10 to the power of negative 5 meter squared. So, ang area ang area dani sa cross sectional area dani sa duha is gi nara. The area is equal to A equals pi r square. So pi is equivalent to 3.14 multiplied by the diameter, which is the diameter is 1 centimeter into meter, 1 centimeter. Kay radius man ang radius is half of the diameter, so 0.5 centimeter. Then ang 0.5 centimeter into meter is 0.005 meter. So pi r square, which is pi is equivalent to 3.14 multiplied by the square of 0.05 meter, which is the radius, is equivalent to 0.0000785 meter square, is equivalent to 7.85 times 10 to the power of negative 5 meter square. So after that, the thermal conductivity of steel is equivalent to 80 watt per meter degree Celsius, and for the aluminum, 220 watt per meter degree Celsius. And the temperature hot of the steel is 100 degrees Celsius, and its temperature cold of the steel is 0, is unknown. Unknown. So ang sa temperature cold is belong sa aluminum, which is ang temperature hot sa aluminum is also unknown. So first step, or the first thing we do is to find, or we will write an equation para makita nato ang value sa T, sa unknown nga T. So gigamit nato ang formula sa rate conductive of heat transferred, which is mag-una ta sa steel. So the rate of conductivity of steel is equivalent to the thermal conductivity of steel multiplied by the area of steel, then multiplied by the TH minus TC all over the length of the steel. So substitute the known values. 80 watt per meter degree Celsius multiplied by 7.85 times 10 to the power of negative 5 meters square, and multiply by 100 degrees Celsius minus T, which is the TC is an unknown. So ang sa TC dani nga given sa steel is T lang, kay unknown pa man siya. So all over 0.25 meter. So after that, gimultiply na ako ang thermal conductivity o ang area, which resulted to 0.00628 watt meter degrees per degree Celsius. So katong meter na multiplied gi-cancel na ako. So nabili na sa pikat sa meter square. Meter multiplied by the watt per degree Celsius equivalent to watt meter per degree Celsius multiplied by the 100 degrees Celsius minus T all over 0.25 meter. So, in this situation, gi-divide na ko una ni sa kani. So, divide na ko, which nag-result siya sa 0.0251 watt per degree Celsius multiplied by the 100 degrees Celsius minus T. So, first equation, kani, sa steel. Then, dinhita sa second equation sa aluminum, which is isubstitute na to ang mga known values. nasad same formula nga gi-use, but di ba dili sila pareha sa thermal conductivity. So at sa temperature. So substitute na to ang known values. Ang dini wala ang temperature hot. So by the way, the rate conductivity of heat transferred is equal to the rate conductivity of heat transferred of steel is equivalent to the rate conductivity of the heat transferred of aluminum. So mo na to buhaton unya after makuha nato ning isa ka equation sa P aluminum. So substitute the given values or the known values. So the thermal conductivity to 220 watt per meter degree Celsius multiplied by the area 7.85 times 10 to the power of negative 5 meters squared multiplied by T, which is the TH is the known. T minus the TC is equivalent to 20 degrees Celsius. So after that, multiply na ko ang thermal conductivity. Repeated lang siya, same as steel nga steps. So after that, nagresulted siya sa, after multiplying the thermal conductivity and area, nagresult siya sa 0.01727 watt meter per degree Celsius. So multiplied by T minus 20 degrees Celsius all over 0.25 meter. Again, divide na ko to get the second equation nga nag-come up sa equation nga 0.06908 watt per degree Celsius multiplied by T minus 20 degrees Celsius. So after that, kay nakuha na nato ang both equation. So mag-derive na ta siya sa formula nga P steel is equal to P aluminum, which is joint atong gipangita ang temperature joint, so equivalent to siya para makita na to ang temperature. So para makita na to ang temperature joint together with steel and aluminum. So copy the equation nga atong nakuha kaganina sa P steel o sa P aluminum. So 0.0251 watt per degree Celsius multiplied by 100 degrees Celsius minus T is equal to 0.06908 watt per degree Celsius multiplied by T minus 20 degrees Celsius. So after that, gi-multiply na ko ang 100 degrees. Isa-isa na ko gi-multiply. So 100 degrees Celsius multiplied by 0.025 watt per degree Celsius. So nabilin 2.51 watt. Then copy. Kaya i-multiply man na to. Copy copy lang ni Dani. Also Dani, same copy, then multiply. Muning ni result. After Dana, ako siya, ang naay mga variable, giusan ako sa left side. And kaning mga whole number na siya ha. What is kana iyara ng sa to gana niya sign. Whole number gitampo na ko dinhi sa right side. So after that, gi-plus na ko ang both left side and right side. So after that, nakuha na ko ang ilang sum. Gi-divide na ko ang constant sa variable para ma-eliminate ang constant, mabilin ang variable para makuha atong gipangita nga 40.7 degrees Celsius. So ang joint, the temperature at the joint. So ang pangtan is what is the temperature at the joint? So therefore, the temperature at joint together with the steel and aluminum is equivalent to T equals 40.7 degrees Celsius. After that, kuhaon pa na to ang rate of heat conduction. So, kato, same sa equation nga gisuma na to ganina, ato lang to ikapit, tas bayloan ang value sa T para makuha nato ang rate of heat conduction. So, kato multiply gi-minus nato ning temperature. After that, nakuha nato 59.3, multiply nato sa 0.0251, then nag-result siya sa 1.49 watt. Therefore, the rate of heat conduction of the steel is equivalent to 1.49 watt. And also sa aluminum, same as steel steps nga gibuhat, at orang gipulihan ang T, then nag-result siya sa the rate of heat conduction of the aluminum is equivalent to 1.43 watt. So example 1.12. The average person produces heat at the rate of about 120 watt when at rest. At what rate must water evaporate from the body to get rid of all the energy? For simplicity, we assume this evaporation occurs when a person is sitting in the shade and surrounding temperatures are the same as skin temperature, eliminating heat transfer by other methods. So, energy is needed for this place change equals Q equals MLV, or the latent heat of vaporization. Thus, the energy loss per unit time is Q over T is equal to MLV divided by T is equivalent to 120 watt is equivalent to 120 joules per second. So we divide both sides of the equation by the LV to find the mass evaporated per unit time. So M over T is equal to 120 joules per second over LV. So LV is equivalent to 2430 kJ over kJ is equivalent to 2430 J over grams. It was the value of the latent heat from a table 1.4. So after that, we will substitute the known value of LV to this formula to get the mass. So 120 joules per second divided by 2430 joules per grams is equal to 0.0494 grams per second is equivalent to 2 grams per unit. So evaporating about 3 grams per unit seems reasonable. So this would be about 180 grams, about 7 ounces per hour. If the air is very dry, the sweat may evaporate without even being noticed. A significant amount of evaporation also takes place in the lungs and breathing passages. So, example 1.13. What is the rate of the heat transfer by radiation of an enclosed person standing in the dark room whose ambient temperature is 22.0 degrees Celsius? The person has a normal skin temperature of 33.0 degrees Celsius and a surface area of 1.50 meters square. The emissivity of skin is 0.97 in the infrared, the part of the spectrum where the radiation takes place. So we can solve this by using the equation for the rate of radiative heat transfer, or the Stefan-Boltzmann law of radiation. So magamit pa na sa formula ana niya, which is the P net equals the Stefan-Boltzmann constant multiplied by the emissivity multiplied by the area and the difference of temperature 2 to the power of 4 and temperature 1 to the power of 4. So first this is the given. So the Stefan-Boltzmann constant. Constant means given na siya daan nga value, mao na gid na iyang value. So dili na siya ma-change, na gid siya value. And second, the emissivity, which is emissivity of the skin is equal to 0.97, the surface area 1.50 meters square, and the temperature 133 degrees Celsius. and the temperature to 22 degrees Celsius. So, first of all, gi-choose na ko temperature 1, 33.0 degrees Celsius is gi-choose na ko siya sa temperature 1 because temperature 1 is that it was surrounded by an environment with uniform temperature. So it means dagha kanang uniform mostly nga common nga temperature mao na ang temperature 1. So, 'di ba, yun ang 33 degrees Celsius is the normal skin temperature. So, mao ni ato ang temperature 1 and the temperature 2, 22 degrees Celsius. So, before we will derive to the formula, we will convert the temperature degrees Celsius into Kelvin. So, temperature 1, 33 degrees Celsius is equivalent to 306.15 Kelvin, while the temperature 2, 22 degrees Celsius is equivalent to 295.15 Kelvin. So, after that, we will derive to the formula the net rate of a heat transfer by radiation. The P net equals the Stefan-Boltzmann constant multiplied by the emissivity of the skin, the surface area, and the difference between the temperature 2 to the power of 4 and temperature 1 to the power of 4. So after that, we will substitute the known values. After I substitute the known values, first thing akong gibuhat is ako ni gi-minus ang nasa bracket, which is sa PEMDAS, bracket kid mauna. Bracket, ano pa tawagan ni? Open parenthesis. So, after that, giunan ako ni. Gi-exponent na ko, tas gi-minus, which is mag-come up siya sa answer nga 1,196,138,908.23 Kelvin to the power of 4. So, after got the difference, gi-multiply din ako siya isa-isa. So, kaning difference, gi-multiply na ako sa area. After I multiply the area and the product of this, I multiplied to the emissivity of the skin, and the product of, I multiplied the product, I multiplied to the Stefan-Boltzmann constant, and I come up to the answer negative 98.6 watt, or converted, or ma-round up siya so negative 99 watt. Also, if the temperature 2 is greater than temperature 1, there is a possibility that the net of a heat transferred by radiation is positive. That is, the net heat transfer is from hot to cold. Therefore, kay mas dako man ang T1 is greater than T2. Therefore, the quantity of P net is negative, and that is the net heat transfer is from cold to hot.